Assalamualaikum warahmatullahi wabarakatuh, and very good day to all of you. So today I want to cover a subtopic 1.5, which is polar coordinate. So let's see the figure here. So we have a polar coordinate system in a plane consists of fixed points O here, which we call this one as pole, okay, or origin, and a ray emanating from the pole, okay. This ray emanating from the pole, we call it as polar axis. Okay, so this one is polar axis. In such coordinate system, we can associate any point P in the plane with a pair of polar coordinates r theta. Okay, so we can draw any point P, okay, in polar coordinate. We can draw any point P, let's say this one, which consists of r and theta. Okay, so this one is from pole, okay, and theta give the directed angle. So theta here give the angle between the polar axis and the line here, okay, that connected the pole with the point P, okay, and the r is the distance between P and pole. So you have r here, so r is a distance between P, the point P, and the origin, or we call it as pole. Okay, so the value of theta will be positive when it is measured counterclockwise. So if you have a value of theta equal to positive, okay, positive value means that our theta is measured counterclockwise from here to here, okay, from the polar axis counterclockwise. While if your theta is in negative value, means that our theta is measured clockwise, okay, so our theta is measured in this direction, so our theta will be in negative value. Okay, if it's in this direction, our theta will be in positive value. Alright, so we have case that we have the point negative r theta. Okay, let's say here is the point that give us r theta. We have another point, let's say point Q, okay, let's say point Q, which coordinates negative r theta. So where is point Q? Point Q actually lies on the same line as r theta, but it's reflected opposite side of the pole. Okay, so here we have r theta, okay, so the same line of r theta is along this line, okay, means that our Q negative r theta actually lies on the same line at the opposite pole. So if your direction, okay, if your r distance from pole to your P is equal to 5, therefore the distance from your pole to point Q, okay, also equal to 5. Okay, so this here is negative r theta, okay, where P and Q, okay, this one is point Q, where P and Q share the same distance. Okay, the value of r is the same for both P and Q, but the value of theta for Q is actually theta plus pi. Okay, the theta here, the theta you get here, you plus with pi is the theta for point Q. So this one is basically a polar coordinate system. Okay, let's say we want to position a few points on our polar coordinate system. Okay, let's say we have point 2 pi over 3, we have point 5 negative pi over 4, and we have point negative 2 4 pi over 3. So you need to know that in polar coordinate system, this one represent r, where r is the distance from pole to the point, okay, and this one represent theta, where theta is the angle from your polar axis to the line connected pole to the points. Okay, so now we have axis x and y. So let's draw our axis x and y here. So we have y-axis here and x-axis here. Okay, we want to position our first point 2 pi over 3. Okay, so you know that when the value of theta is positive value, means that our theta is measured clockwise, counterclockwise. Okay, so from the polar axis, let's say this one is our origin, therefore this one is our polar axis. Okay, so our theta will be directed like this, okay, counterclockwise. Therefore, if you see the first point, we have theta equal to pi over 3. So pi over 3 is equal to 180 divided by 3. Therefore, we have pi in theta equal to 60. Okay, so let's say theta is equal to 60 is here. Okay, so this one is the theta equal to 60. Okay, your theta equal to 60, and let assume the length of this line that connect your origin and your point is equal to 2. So therefore, let assume this one is point P with 2 pi over 3. Okay, with the coordinate with the length of the line connected the pole and the point P equal to 2, and the angle is 60. Okay, let's move to the second point. We have the line with the length 5 and the angle is negative pi over 4. So if you see here, your angle, your theta is negative, means that it's measured clockwise. Okay, it measured clockwise. Okay, therefore we have negative pi over 4. Negative pi over 4 is 45. So let's start from your polar axis here. So you will have the theta equal to 45 here, and let's assume the length of our line now is 5. Okay, so this line with length 5 actually connected the pole with the point, let's say R. Okay, so here we have the point R. Okay, where point R have the theta equal to negative 45, and the length of the line equal to 5. Therefore, you have a polar coordinate 5, negative pi over 4. Okay, so let's see the third point. If you can see here, the value of R with the first point is the same, and if you see the theta for this third point is actually pi over 3 plus pi. Okay, so this one is the theta for the first point P here. Okay, so the third point here have a theta pi over 3 plus pi, means that this line, this point lies on the same line with point P, but then at the opposite side of the pole. Okay, so we have a line, straight line here. So the point S, let's say this one is the point S, lies on the same line but the opposite side. Okay, so if our point P have the distance 2, this point S also have the distance to here. So here is our S with negative 2, 4 pi over 3. Okay, so you can see why we said that this point have angle theta plus pi, because the angle starting from here. Okay, so you have theta up to here. Okay, then up to here you will have theta, then you plus with another 180, where 180 is equal to pi. Okay, so here you have the total angle is theta plus pi. So this one is how you want to position a few points on the polar coordinate system. Let's try to plot a few following points in polar coordinates. Okay, let's say we have A point 40. Okay, for B we have point 2, 3 pi, and for C we have point 2, negative 2 pi over 3. Okay, so let's try how to plot this point in polar coordinate system. Okay, so for the first one, we have point 4, 0, where in polar coordinates we know that 4 is a distance from pole to the point and 0 is the theta or the angle. Okay, so if we have a axis x and y here, so theta equal to 0 means that you don't have any directed angle, therefore your line 4 is just on the polar axis line. Okay, so this one is your pole, so your point is here, so the length from pole to the point is 4. Okay, so this is where your polar coordinates point 4 is positioned. Okay, 0 is position, sorry. Okay, for the second points, okay, for the second point, if you want to plot in the polar coordinate system, okay, you know that from pole to the point you have a distance 2 and your theta is 3 pi. Okay, 3 pi. Okay, 1 pi is equal to 180. Therefore now you have 3 pi and your theta now is positive value, therefore is directed in counterclockwise direction. Okay, so let's start to direct our theta first. So we have 3 theta and 3 pi. Okay, we start here from our polar axis. Here to here is 1 pi. Okay, here to here is 1 pi. Here to here is 2 pi. And we have until here is 3 pi. So this one is our angle. Okay, and means that our line, okay, falls in this polar axis, okay, with the distance equal to 2 from the pole here. Okay, so here is our 2, 3, 5. Okay, next we have points 2, negative 2 pi over 3. Okay, negative 2 pi over 3 is equal to 120. And if you can see your theta is negative, mean it is directed clockwise. Okay, so let's direct our theta first. So 2 pi over 3 is 120. So from here to here you have 90. Let's say this one is 120. Okay, therefore you have line from pole to the point where the length of the point to pole is equal to 2. Okay, therefore this is the coordinate or the position for 2, negative pi over 3, where this one is your theta. Okay, so this is how you want to plot your points on the polar coordinate system.